Hello and good day to Dr. Nobakia and Dr. Selisa. Today we will present you our mini project named Airflow Detector. Now let's start.
Next is introduction. Airflow detection was frequently required in various applications or systems where the presence of air was required to provide a descriptive image of the system's proper operation. This gadget was used in high power density electronic device to detect the rate of air movement inside the device and prevent it from overheating. The airflow detector circuit was commonly utilized in various appliances because it provides a visual indication of the rate of airflow. This circuit was employed anywhere it was necessary to detect the rate of airflow or the presence of air, as it delivers a clear picture of air in each place. For example, the most common example of airflow detector circuit is engines. This circuit was applied in engines to estimate airflow within it so that we could determine how much more fuel we needed to add it for it to function properly. Next is objective. First, adding in-depth knowledge in the use of multisim. Second, list the component and software used while running the project. Third, explain the process of running the project. And lastly, 4, describe the result of the project before and after it is carried out.
Assalamualaikum and hi, my name is Nafatia binti Syarifuddin, matrix number S64708. I will continue to the next presentation, which is methodology. First, the students will start with a briefing from the lecturer, and next is a preliminary, which is to show all the information and requirements such as components and software, and then the student will continue to data collection. Data collection is an important aspect in any field of study. At this step, the student prepare for the project resource and requirements, as well as lecture studies and a timetable for gathering further information for this study. So during the data collection times, the student discovered a paper about the airflow detector on the internet, and also the students tried to find the electronic components, other supplies and part of equipment have been employed. Next, during the planning phase, the student conducted research on the project, which include a study of capacitors, resistors, batteries, temperature sensor, LED, IC 555 timers and diode. The research is not only for the function of the part but also for the types of miniature circuit built by each part. Furthermore, the student continue to data processing and analysis, which is the student find the component requirement and the software requirement for this project. For the software requirement, the students use multisim software. Multisim was industry standard SPICE simulation and circuit design software for analog, digital and power electronics in teaching and research. Next, the students continue report writing, and then the student will end with conclusions.
Okay, let me explain about the circuit before the run. We use some components that are DC power, capacitor, LED, resistor, ground, signal, IC virtual and change sensor reading. The function of the capacitor is to store and dispose of change and as a voltage stabilizer in the circuit. Besides that, the function of LED is allowing electric current to flow in one direction and emit light. We use regular LED. After that, the function of the resistor is to control the electric current according to the resistor value. In addition, we use signal. The function of signal is a driver for all popular operation systems. Lastly, we use the change sensor reading to read the temperature in the airflow detector. The sensor can be exchanged from 200 to 540. Okay, so let's see after run.
This circuit is operated using a 12-volt battery. The battery voltage is regulated using the xenodiode, which produces a constant voltage. Initially, as current flows through the RTD, it gets heat up and its temperature increases, thereby increasing its resistance. The resistor use different value such as R1 equals to 390 ohm, R2 100 ohm, R3 10k ohm, and R4 10 ohm. The RTD selected here is HEL 700 TOA with a maximum operating current of 2 mA. Here we are using a xenodiode 1N4732A as a voltage regulator to provide a constant current to the RTD. For the first try, we use T equals to 130. The timer get triggered and the LED start blinking. As we can see, like here, the result show that the LED blinking so fast when using low intensity. To see the difference, we use 5 different temperature sensor value, which are T equals to 130, 235, 340, 420, and 540. Okay. As a result, T equals to 235, LED blinking slightly slow than before this, which is T equals to 130, like in this circuit. Okay, next. When T equals to 340, the result show the LED blinking slow than T equals to 130 and T equals to 235. This provides a clear indication of airflow in the engine with the help of this circuit. The brightness, which is the output result, varies according to the airflow throughout it. Now, look, when we use another value, T equals to 420, the LED move to blinking is slower than others. When use high intensity, we can see the difference of LED moving slow here. Last but not least, when temperature sensor or T equals to 540, LED begins so slow than others. Okay, see the difference here. The LED move getting slow than before. It happened because the higher the intensity, the slower the LED blinking.
So, the conclusion in this project, students have finished the project with the state average result from both sides, which are after the run and before running the circuit using the multisim. Students also state some research methodology to finish this mini project and choose a flow detector as the title of this project. The goal of this project was gaining in-depth understanding about multisim, listing the component and software utilized while running the project, explaining the process of running the project, and describing the project finding before and after it was complete. There were numerous examples of application of the air flow detector that students had studied during this project so that the knowledge gained for this research could be put to good use and implemented in their daily life. So that's all from us. Thank you.